Alright, we're doing this again because I forgot to turn my email client off. Alright, so today's tutorial we're going to talk about a number of things. So we'll go back to what we did last week. So last week we had a little sprite and it has this command. So we learnt about the repeat blocks and we learnt about functions, which are things that start with a name and take a value, a parameter. And this is my last video. I just discussed this. Sometimes these things are called parameters. Sometimes they're called arguments. We just say that they're function values, and you pass the values into the function. And that these things, so things that have a name followed by a round bracket followed by some argument values are functions, except in some cases when they aren't, they just look very similar, like repeat for. Today we're going to learn about a few other things. First we're going to learn about the command print. So if I go print hello and then we go like that, you can see that it prints some text on the side. So that's all it's doing, is it's printing out some text. Right? But this thing can take as many argument values as you want. So if I go hello world and type properly on the keyboard, this takes 2 argument values now. We're giving it 2 argument values and we're dividing them up by putting a comma between the different values. So I have to have a comma between those values. And this thing here is a string or a piece of text. So in the computer world, a piece of text is often called a string, and often is written by having these double quotes at the beginning and the end of the text. So the double quotes means anything between those 2 double quotes, so the 4 quotes in total, is a piece of text and not to be interpreted by the computer as anything except a piece of text that we're passing around. So if we run this, you can see it prints hello world. So it's put those 2 things together on the same line, and so on. If you want to put a double quote in your string or your piece of text, you go that backslash and then the double quote. So that is, backslash means don't interpret that double quote as the end of the string, only interpret this one. And if you want to do a backslash, you type 2 backslashes. So that's just if you're writing really complicated, weird things. I would just normally write a single quote because a single quote doesn't mean anything within double quotes. Okay, so that's multiple argument values for these things. But you can write more complicated things. So I can go 1 plus 2 equals 1 plus 2. So the things that go here are not just single things. They're not just a piece of text or a single number like I've used here. Sorry, I have to have a quick drink. Instead, they are what we call expressions. So an expression can be a simple thing, like a number or a piece of text, or it can be a more complicated equation that links other little expressions to make a bigger expression. So in this case here, plus is taking these 2 expressions of 1 plus 2 and making them into a third thing, which is going to be what 1 plus 2 is. So the computer is not going to print out 1 plus 2 equals 1 plus 2, because this is not a string. This is not surrounded by these double quotes. And so in fact what the computer is going to do is it's going to work out first off what is 1 plus 2, and then it's going to give that thing to the print command or the print function. I just realized I called these things commands and functions sometimes. I'm going to put them around interchangeably most of the time. So this print function or print command takes whatever number of arguments you give it, and each one of these is evaluated first, then before it's given to the print command. So it's going to evaluate, which means the computer is going to work out what 1 plus 2 is and then give that to print. So when we run this, it's going to say 1 plus 2 in very small writing. I should have made the font bigger for this. That's not an option yet, so tough luck. But 1 plus 2 equals 3, which I believe, though don't get me don't quote me on this, is actually correct. We can do more complicated functions. So I can go, say I wanted to do some trigonometry, and I wanted to go, what is the sine value of 90? So what's the sine of 90 degrees? Well, I can actually just write that here. I'm going to write, I don't have to put the brackets there. Well, I can. Sine, or sin of 90. So on the computer world, they usually just say sin, cos, and tan, and they don't write sine. So I could write sine of 90 equals. So this is why sometimes they're called functions. So this is a function called sin that takes a single value, which is the angle in degrees, and gives you the sine of that value. So print is going to be passed, not 90, not sine 90 or sin 90. It's going to be passed the value that this function returns. And this is a built-in function, so that's where it's coming from. So if I do that, it will say sine of 90 is 1. So it works in degrees, not radians, because that's what Scratch does. There probably will be at some point a sine R command, which will be sine in radians if you're a maths nerd. Right, so that's just an example of a more complicated function. Okay, so the next thing we're going to talk about is variables. So variables are very important in programming. In fact, like, you can't get anywhere without variables. They are, you can imagine them like little boxes that hold information that you can sometimes change and sometimes you can read them. I say sometimes because the first variable we're going to start with, actually, first thing we're going to do is learn a new command. So we've learnt print. Second command we're going to learn is goXY, and that takes two values. The first one is the x coordinate, 100, and the next one is the y coordinate, 100. And I'll talk about what those numbers mean in a second, so we can get rid of that line. So I'm commenting things out by putting the slashes in the front. If you want to do divided by 180, it's that symbol there. So that slash is division. If you want to do multiplication, it's a star symbol, so not an X. So anyway, we've got here. So as you can see in that function, that expression is quite complicated. First off, I had to do this, calculate what 180 divided by 2 is. Then the computer passes that to the sine function, and then that value is passed to the print function. One other thing, sorry, I have to go about it. Print 1 plus 6 equals 1 plus 2 times 3. And I put the equals in the wrong place, and I put comma. I'm trying to avoid doing the semicolons. So one thing, it evaluates basic maths like you in general, like you do properly, like bod maths or whatever you're going to call it. So the multiplication is done first. So this would be 1 plus 2 times 3. So 1 plus 2 times 3. So 2 times 3 is done first, which is 6. And then we add that to 1. So we get 1 plus 6. It's not 1 plus 2, which is 3, multiplied by 3, which would give you 9. So it's not going to say 9, unless you put brackets around them, and then you say 1 plus 2 times 3 is 9. But anyway, we'll leave that in there for now. We'll also do this. So this goXY, also, you can write that as moveTo. So there's two ways of writing that command. We'll go with moveTo. So moveTo is going to move. So we can look very quickly on the layout. It's in the middle of the screen. So when we run it, what happens? It's not in the middle of the screen. It's moved. So the x coordinate is the position along the horizontal way. And it's a number that is 0 in the middle and negative as you go to the left and more positive as you go to the right. So it increases going to the right and decreases going to the left. Negative values are on the left hand side, positive values on the right hand side, left hand, right hand. Y values, similarly, they go Y as you go up, you are increasing, and they are positive when you are on the top of when you're going up the screen. And when you're lower than the halfway point, they are negative values. So as they go down, as the y value decreases as you go down. As you can see here, it gave the wrong value. It says 1 plus 6 equals 9. So if you looked at so now you can see this is up here. So the y value is positive and the x value is negative because it's moved from the center, which is what, as you may remember, the code says. So the x value is the first argument value, and the second one is the y value. Now we're going to learn our first command, and we're going to learn a new type of loop. So we've done repeating, so we can repeat a number of times, but we can also do forever. So this is just like in Scratch. Scratch has its forever block, and this is forever code. Unlike Scratch, you can write code like this, where this bit of code will never ever happen because it's after the forever block, and this will go on forever. But instead of moving, get rid of some of this code. Instead of moving to a set value, we're going to use our first variable, and our first variable is a built-in system one, and it tells us, well, there are two variables, and they help us find out where the mouse pointer currently is. And to write a variable, it's very similar to writing a function. You just don't have the brackets and the argument values. So the name of the variable that tells you the x coordinate of the mouse is mouse with a capital X after it, mouseX. The way that these things are written, this is called camel text. It's just because they go up and down like the humps in the back of a camel. But basically, you write a word and every new word starts with a capital letter. So that's why this is a capital T, because it's the next thing. So mouse and then X. Sometimes, some languages, they want you to go move_to, and they would write mouse_X, something like that. And this version of Glitter, it doesn't. That's the style is to write them in like, so this is kind of like Java style. There may be a Python version, Python-like version, which I hope there will be one day, where you can write them like that. You can write them whatever way you want, but this is the style that I would recommend, and this is the style that the standard commands are in. So next thing, mouseY. You kind of might have guessed that one. So this is going to forever moves the sprite to the current position of the mouse and the X position. So the X position of the sprite is going to become the X position of the mouse, and the Y position is going to become the Y position of the mouse. So when we run that, and we move the mouse, then the sprite follows the position of the mouse pointer. So that was quite handy. And of course, if we change these things around, it just becomes confusing. But we are going to print out mouseX, mouseY. So there is a couple of there's an extra comma in there. That comma here is the comma that I'm adding to the text that I'm printing out. So it's not part of the code. So this is a piece of text, and that comma is inside of that text. So it's not a divider between the argument values because it's text. So the computer is ignoring that and not interpreting it as code. So now when we run this, you can see that it no longer goes to the mouse pointer because the X and Y are swapped around. So as I move to the left, it goes down, and as I move up, as I move right, it goes up, and as I move up, it goes right, and as I move down, it goes left. But you can see as I move around what the X coordinates are. So if I'm over here, the X coordinate is 218, and the Y coordinate is -166. And if I go up, you can see that it's positive. So you should be looking at the stuff on the side here. I've kind of gone and lost the mouse pointer. I don't know what happened to that. That's kind of interesting. What happened to my mouse pointer? I mean, what happened to my sprite? It's there. Huh. Strange. A quirk that I don't know about. But we'll come back to that one other day. So you can kind of see the idea of those kind of things, variables. Give me a second. I am still recording. 15 minutes. All right. So now we're going to, this is where it gets exciting. We're going to learn about another, we're going to comment it out for a second. Another variable. That is spriteX. So in the case here, we've just read the value of the variable mouseX or mouseY by passing it to as a, so when we're writing an expression and we want to have that expression to be the value of a variable, we just type out the name of the variable. So if I want this to be that, I could, coming back to that in a second, I could make a more complicated expression, plus 50. Actually, we'll just do that. mouseX. No, actually we won't. We'll do 100. Right. So as you can see, now the mouse moves there, but it's to the side. It's not matching the mouse pointer. It's the mouseX plus 50. So we can do these kind of more complicated expressions. But say, like the things with variables is that sometimes you want to change the value of the variable. You can't change the value of the mouseX because that's the mouse pointer and you don't have control over the mouse pointer. But you can change the position of the sprite. And you can use the moveTo command, but you might want to just do it directly. So if I wanted to change the spriteX coordinate, I can say minus 150. Right? So that's my entire command. We can get rid of this now. And if we run that, you can see that the sprite is to the side. It's moved all the way over there. So now if I bring this back, I can replace this piece of code with this piece of code. mouseX spriteY equals mouseY. So let's see what happens. And we end up back in the same position we were beforehand. So there's another way of writing the code we did before, where the spriteX and the spriteY, we just read it, so that's what they equal. So this is the thing I forgot to mention. The equal symbol is the thing doing all of the work here. The equal symbol means take everything on this side and put it in this variable. So it's not like in maths. So if you're up to this point, you're all like, oh, algebra. This is different to algebra. You're not saying that, well, you are saying in a way, you're not making a statement about the world that mouseX and spriteX are the same. You're saying make spriteX be the same as mouseX. And I'm going to make another example that's going to emphasize that a little bit more. So we can do slightly more complicated bits of code. Well, I wonder what did you do that for? All right. And then we're going to say spriteX equals spriteX plus 10. And this might seem strange. You're like, I think when the first time someone sees this, they're going to, especially if you're thinking algebra, you're going to be like, ooh, this doesn't make sense. How can spriteX be itself plus 10? What value is spriteX going to be for that? Well, you're not making a statement about spriteX. You're saying spriteX is going to become spriteX plus 10. And that might also feel a bit weird because you're like, well, how can I set spriteX to be itself plus 10? If I change, so because as soon as I change it to like add 10 to it, then I have to add 10 again, don't I? Because it's doing it over and over again, and it's like I don't know what the value should be. The way to think about it is this side is evaluated or worked out by the computer first, and then it is stored in the variable. So we work this value. So once you've stored, so when you store the new value in here, it doesn't have any effect because this was reading the old value of spriteX. So this is going to read the old value of spriteX, the current value, and then it's going to add 10, and then it's going to change spriteX to be that new value, and that's it. And it's going to do this 10 times. So remembering that as we increase the x value by a number and it gets more positive, it's going to move to the right. So have a second to guess what might happen, and if that's what you thought it would be, you were right. So if I keep pressing that, it will go off the side. When you use spriteX directly, or when you use moveTo or goXY, sprites are not fenced. So that's the term that they use in like Scratch and Turbo Warp. It's not bounded by the area of the stage, so they can go off to the side of the stage, which is what's happening here. So now this sprite's moving all the way over to here. So you've got that, and again you could use spriteY, so spriteX, spriteY, and that's how those things work. So the very next thing that I want to talk about is actually the remaining thing I'm going to talk about for this video. I was going to get on to more complicated stuff, but I think we will go with user variables. So these variables are built in to Glitter, like they're given to you, they're provided. You don't have to do anything about them. But if you wanted to, and almost certainly every single computer program you ever write will require you to have temporary storage space. You need to put things in certain places. And that's what variables are for, or user variables. So the thing with variables that you are making and using yourself is you have to declare them first. And in Scratch, you have to declare things outside of the event block. So if I get rid of this code for now, remember this is a flag block, and everything between these two curly brackets is part of the flag block. But variables mostly should be declared outside of event blocks. This will change. This is actually what I'm working on at the moment while I'm doing these videos. But for now, we have to declare them. And how do you declare a variable? Well, it's kind of similar to assigning a value. This is called assigning a value to a variable. You have to add just one extra thing. What that is can change though. So Glitter has a number of ways of declaring variables. We will start with a simple one. We will use the var keyword. So we might go var cat equals 4. All right, and then I will get rid of that code. Now we'll go print cat is cat. All right, so this is going to first off work out what cat is, and then it's going to pass that to the print command, which is going to print that value out. So when I run this, it will say cat is 4, which is correct because cat is 4. But what if I go cat equals 6, 5, 6? All right, we'll go cat, and then we'll do print cat. Now, when I run this, it's going to say cat is 4, and then it's going to say cat is 6. So you have to remember the order that the computer does these things. So the first print is done when cat is 4, because that's what it starts off with. This is the default value. So you have to give a variable an initial value in this language. That may change, but you have to start off with the initial value of 4. So when I print this thing, the value of cat is 4, and then I reassign it. So this is an assignment again, and I'm not redeclaring it. I'm not using this var. So the var is the thing that tells the computer that this is a declaration. So this is saying this is a variable that I want to use. And I'm going to talk a bit about why you have to declare things soon. But down here we reassign it to 6, and then when we do the second print, cat is 6. Now I don't know if anyone might feel this way, but you might feel like, why doesn't it print out 6 twice? Because I changed it to 6, so it's cat is 6. Why does it not change? Well, because you printed this out, and it's like you're writing it on a piece of paper. It's fixed. It doesn't matter, you know, that you changed it afterwards. It was 6. It was 4 when you wrote this down. It doesn't matter that it's 6 now. So it's going to say cat is 4 first, and then it's going to say cat is 6. You have to declare a variable because you can't use variables that don't exist. So if I misspell this with a K, right, cat, it's going to tell me the variable cannot be found within scope. So I click on this. So it doesn't like this. It says the variable cat cannot be found within scope. And that just means you haven't declared it. There's no variable named cat that it knows of. So you can't just go using things. And you might think, well, that's a pain, but it helps a lot, because if you misspell something, your code won't work. Like if you've misspelled it as cat, and that was fine, and it just goes and makes another variable called cat with a K, then it's still going to say 4 here. You haven't changed the variable that you wanted. And in a more complicated code, you won't realize that. So you need to declare things first so that it knows the actual name of the variable. And if you try and declare another thing called cat equals 5, it's just going to complain that you've already declared cat. So you can see here you've got 2 error messages. The first one, the variable cat is repeated within scope, so you don't worry too much about the scope thing. It will make more sense as you get more advanced decoding. But it's just saying that here you're redeclaring another variable. You only declare it once, and then you reassign it as you need to do so. Right. And of course, you can do more complicated stuff. So var dog equals 5, and then you can say cat equals cat plus dog bracket times 2, right? Which I think makes sense when if you understand animals. So this is going to say what is cat? Well, cat is currently 4, and then we're going to add in dog. So that's 5, that's 9, times it by 2, that's 18. So it should say cat is 18, and voila, cat is 18. So we've reassigned that. So again, this can be a complicated expression. You can't say cat plus 2, right? You can't say cat plus 2 equals. This is not algebra. This is an assignment. This thing on the left-hand side has to just be the variable name, right? It can't be anything more complicated. It's just the variable name, and it equals that thing there. Right. So the next thing I'm just going to talk about, and I'll finish this video there, is typing. So I am a supporter of typed languages. But Scratch is not a typed language. Lots of other languages aren't so typed. And typing just means that a variable has a type of thing. What is cat? What kind of thing does this box? So cat's a little box that you put things into and take things out of. What kind of thing is cat? So is it a thing that holds numbers, or is it a thing that holds strings? So strings, again, the things that are between the quotes, is a string of text. So we've seen 2 types of different things that you have when you're programming. One of them is a number, and one of them is a string of text. So in an untyped language, you can put whatever you want into the cat variable. So you might be able to say cat equals 5, and then the next minute you might go cat equals 6, like as a piece of string. Sorry, it's a string of text. All right, and that's fine. That's fine. This, though, is probably going to complain. It's going to say the type string is invalid in this context. It's expecting an int. So when you use the var keyword, unlike in JavaScript, it's implicitly working out the type. So it's saying, well, what is 4? 4 is a number, so cat is a number. You have to put those kind of numbers into cat. You can't go putting anything you want. You can't go putting a string into cat. Right? If I wanted to go moo equals cow, right? Now moo is a string, right? But moo is not a number, right? Because that's the first thing you put into it. Except that didn't work. Oh right, it's gone and converted the 7 into a string. So sometimes it doesn't go backwards because it's converting the 7. So moo has to be a string, but it's just saying, well, you put in 7, you must mean this. But you can see that it's fine to put the word 6 into moo because moo is a cow, is a string. But there are other ways of declaring variables. So normally you would specify the type of things. So the two types that we've seen so far are int, which is an integer, so which is what these things are. So I can go int cat and int dog, and I can try saying int cow. So int for integer. You don't have to write integer every single time. You just write int. All right. But if I compile that, it's going to say there's an error here. So you can't put a cow, the text, into moo because you just said that moo is an integer. So this is the explicit typing. Var is the implicit typing, or where you just guess the type from what you typed here, and this is where you actually say it out loud. So that would be fine. So if you wanted to actually get that to work, you have to say what it is. Well, what is it? It's a string, so you have to write string, and you can write string with a lowercase s and an uppercase s. That's just because in Java it's with an uppercase s, and I'm trying to help people to be able to code in different languages. So you can now see that that will, in fact, compile. So again, everything is happy. Print moo is. We'll keep it like that. Moo. All right. So moo is 7, cat is 6, cat is 22. How did we get to cat? Oh, because cat now has become 6, right? Okay, so that's that. But okay. If you really don't want to type things, you don't care, you can declare variables to be untyped. You can just write any moo equals 4, all right, and then you can say, we have to get rid of this one first. So this says moo can be anything. That's what that means. Moo's anything. So this is kind of like Scratch, which is untyped. So you can then put anything you want in there. Sometimes this thing lets you, hopefully we'll be doing microprocessors and Commodore 64s and other things. You will not be able to do this in a Commodore 64 setting. You will have to be very explicit about what kind of type things are. But in general programming things, you can get away with this kind of stuff. I do not encourage this. This is mainly there to provide some compatibility with old Scratch projects. I would avoid that. The other way of doing things is you can go let cat equals, let bird equals 6. It won't work. It will say incomplete parse for some reason. I don't know why I didn't actually just let it do that. I'm sure there is a reason, but in this case you have to write it in a different way. So you have to say let bird of type int equals 6. And I've gone and forgotten about moo. Alright, so that's another way of writing and declaring variables. You can use the let keyword, and then you have to go colon int. So again, that's explicit typing. It's just a different syntax. So in my advice, I would just get into the habit of declaring the types of things. There is one case where you might not want to use var, which is this idea of floating point numbers. So this is an integer. So 4 is an integer. If you've forgotten your maths, an integer is just a whole number. It's like, well, not a whole number, but it's a number that doesn't have any fractional part or any decimal part after it. There's nothing after a decimal point. So it's 4 or it's -4 or it's 0, but it's not 0.5. So if I went like 6.5, it's going to complain. It's going to say the type double. So it calls these things doubles, which seems a bit weird. It could say float. And in fact, you can fix this by changing it to say a float. So in the world of computers, these kind of numbers are stored in what is called floating point format. So it doesn't matter too much about what that is, unless you really care about underlying computer programming things. But it's just explaining why these things are given these weird names, when you might say, well, it's a rational number, or it's a real number, technically it's a rational number. So why don't you just say rational or rat? You could call it rat. Maybe I will put in rat, but I feel like rat cat. It's a bit funny. So you can say float, or you can say double, and I always put double, and that's because in like languages like Java, double is what you would normally use. And you might think, well, what's that got to do with rational numbers or anything like that? And the answer is it's to do with floating point. So there are different ways of storing floating point. There's the sort of a baseline single precision floating point number, which is often in other languages when you say float, you mean a single precision floating point number. They take up a certain amount of space on the computer. But if you want a higher precision, but you are willing to give up a bit of space, and how much, it will take more space to store this thing, then you use a double precision number when you declare that as a double. So in Glitter, everything is a double precision number, but you can type float or double if you want. And this depends on how you actually. If you're running this internally, like on the code, then that's what I just said is true. But if you're running this on like a web, if you've compiled it and exported it out as a web page, the behavior will be using the way that JavaScript does, and JavaScript is kind of untyped. The same thing with Scratch. So even though you're saying it's a float here, it's not going to make any difference in the Scratch output. This is just to help you make sure things get the right value. And the reason I'm just going to say float, cat is a float, is because if I wrote var, then it would say, well, this is an integer, so cat is an integer, but I want it to be a float. So I might specifically say I want it to be a floating point value, or I want it to be a rational value. The other way of doing that, of course, is to give it an actual float. And so to do that, you say 4.0. Right. So you want the initial value to be 4, but you want it to be a float. Then you'll see that works. But if I get rid of the 0.0, that doesn't work, invalid in context. And if I do that does work. So any integer value is acceptable for anything that takes a float value. Anything that is a float or a string or a integer is acceptable for something that takes a string value. The only thing acceptable for an integer is an integer. Okay, I had a bit complicated, but anyway, we'll leave it there because I think that was more than I thought. We're going to start getting onto some more interesting code soon. But variables, super important. You have to understand those before you get anywhere. Understanding expressions, super important. You've got to understand that before you get onto more complicated stuff. But there you go. Thanks for watching, and I will see you in part 3, where we will do the more interesting stuff. So bye.